For nearly 50 years, the E-3 Sentry aircraft was the cornerstone of the U.S. Air Force's ability to keep eyes in the sky. In the waning years of the Cold War, and throughout America's wars in Iraq and Afghanistan, the Airborne Warning and Control System aircraft, or AWACS, and its trademark 30-foot rotating radar dome swept battlefields and potential conflict zones around the world. The E-3 Airborne Early Warning and Control System might be the key to American dominance in military operations. Its integrated command and control battle management provides an accurate, real-time picture of any battle space to any joint operations center. It tracks friendly forces, hostile forces, and neutral parties on the ground, in the air, and at sea. The aircraft itself is called the E-3 Sentry, and it's basically a modified Boeing 707 commercial liner with a 30-foot diameter rotating radar dome on top of it. That massive dome tracks radar signals from the Earth's surface all the way up to the stratosphere. It's the U.S. military's all-purpose information nerve center during any operation in any environment, anywhere in the world. With all of that in mind, it seems like the first thing an enemy might do is locate the US AWACS and take it out, blinding the American Joint Force and preventing its interoperability on offense or defense. After all, how hard could it be to shoot down what is basically a civilian 707 with a massive lump on its back? The truth is that shooting down an AWACS will be much harder than anyone might expect. The first issue with attacking an AWACS is the AWACS mission itself. It knows where nearly everyone in the battle space is, friend or foe, and can be in contact with any one of those units. Most importantly, for the defense of the AWACS, it can position itself outside of the range of any ground-based or air-to-air aerial defense system that might be present. It's free to do important work without worrying about pesky surface-to-air missiles or SAM. If it were too close to an enemy SAM site, the moment the SAM powered its radar on, the AWACS would detect it, identify the site as a target, and call on U.S. Air Force and U.S. Navy assets to completely destroy the site as a threat. An AWACS doesn't need to be close to a target. With a range of up to 250 miles, the AWACS can see a radar signature before the enemy sees the AWACS. Any aircraft that managed to scramble off the ground to attack the AWACS could not rely on the ground-based radar system the enemy had in place. By the time the aircraft took off, American air power would likely have destroyed the radar. Once an enemy fighter does make it off the ground, it would have to hunt for the AWACS on its own. Without aerial refueling, the enemy pilot wouldn't allow much time to find, engage, and destroy the AWACS before it would be forced to land. Finding the AWACS on one jet fuel tank is unlikely, considering the AWACS radar is much more powerful than the onboard radar of any jet fighter. The AWACS can see the enemy fighter long before the enemy can see it, and could evade the enemy indefinitely. Most importantly, it doesn't have to avoid enemy fighters. An AWACS can simply call on the many aircraft that are likely already airborne and direct an attack against any enemy air assets that might be searching for it. The F-35 Joint Strike Fighter can see well beyond the range of most likely enemy aircraft and can engage targets at a distance, whether called on by the AWACS, Joint Air Operations Center, or any other command. One emerging problem for AWACS is the increasing range of standoff weapons like long-range missiles. Countries with stealth technology could potentially approach the aircraft and fire off one of those longer-range weapons, attacking the vulnerable aircraft at a considerable distance. China's People's Liberation Army Air Force has stealth technology in its Chengdu J-20A. If a J-20A fired a PL-15 missile, the missile's range of more than 200 kilometers would be able to take down an AWACS. Suppose an enemy air asset could locate the AWACS undetected and prepare to engage. In that case, the AWACS is such an important asset that it likely has its own fighter escorts. In many cases, those escorts would likely be superior to anything most large enemy fleets are flying and would make short work of an attacker. Simply put, there's a reason no AWACS has ever been lost in combat. Attacking one is a suicide mission. However, the U.S. Air Force's fleet of E-3 radar planes was on its last legs. The head of Air Combat Command said the whole fleet was in hospice care, meaning its demise is imminent. AWACS has been pivotal in monitoring airspace and managing military operations since joining the force in 1977. Production ceased in 1992, and the Boeing 707 jetliner on which it is based was retired by airlines decades ago. The problem isn't just that using a 4-engine aircraft when more efficient twin jets are available wastes a lot of money on fuel. Finding spare parts for an airframe designed at the dawn of the jet age is increasingly difficult. Airmen must scrounge in the boneyard for items no longer in production. While the plane has aged out, the airborne surveillance and battle management missions have never been more important. As the focus of U.S. strategy shifts to the Pacific, the Joint Force must be able to surveil the sky over millions of square miles of ocean and adjoining land masses. That requires airborne radars with greater range and precision. The Air Force has a solution. It's the E-7 Wedgetail, a radar plane based on the Boeing 737, the world's most popular twin jet. It was first developed for Australia and is now operated by several allies. In 2022, the U.S. Air Force decided to buy the E-7 to replace the aging E-3 Sentry and plans to retire 13 of them, roughly half the fleet last year, and eventually phase the rest out as E-7s come online. We conducted a thorough analysis of viable industry options to ensure the selected E-3 replacement could meet the specific needs of the U.S., Hunter said. Until the E-7A is fielded, we will continue to rely on the E-3 AWACS.